Hey there. You ever look at something huge, like the Linux operating system or a crazy complex video game, and just wonder, how on earth do you even start building that? Well, for a lot of them, it all begins with C. And today, we're going to break down the 4 fundamental cornerstones of this language, the absolute basic rules you need to build pretty much anything you can imagine.
It's a big question, right? How do you build a universe from scratch? But honestly, when you're programming, that's kind of what you're doing. You're creating this little world inside the computer that has its own logic, its own objects, its own rules.
And just like any universe, you have to start with some fundamental laws of physics. Well, in C, it all boils down to just 4 foundational concepts. Seriously, everything else is built on top of these 4 ideas. If you can get these down, you have the keys to the entire kingdom.
Okay, first things first. Let's imagine you're an architect, and you've got this giant blueprint. You need a way to label everything, right? This is the master bedroom, that's a support beam, this is a window. You need names for things. Well, in the world of C, these labels have a special name: identifiers.
So what is an identifier? It's really simple. It's any unique name that you, the programmer, make up. It's how you give a little piece of your program its own identity so you can refer to it later. It's literally like slapping a label on a moving box so you know what's inside.
Now, you can't just name them anything you want. There are a few simple rules. Your name has to start with a letter or an underscore. After that first character, you can use more letters, underscores, or even numbers. And this next one is super important. C is case sensitive. That means age with a lowercase a is a totally different thing than age with a capital A. And finally, your name can't be one of the special words the language has already reserved for itself. And that little rule, well, that brings us perfectly to our next cornerstone.
So, if identifiers are the names that we get to make up, what are the names that we're not allowed to touch? These are the keywords. Think of them as the special, built-in vocabulary of the C language itself.
Here's the best way to see the difference. An identifier, like player's score, is a name you invent for your own stuff. A keyword, though, like int, is reserved by C. It already has a job, and you can't change it. It's kind of like the difference between naming your own dog Sparky, that's your unique identifier, and the general word dog, which is a keyword with a built-in meaning everyone understands.
So how big is this special vocabulary? How many of these reserved words do you think there are? 100? 1,000? Get this, there are only 32.
That is it. 32 words. It's kind of mind-blowing, isn't it? From this tiny little set of commands, people have built entire operating systems, incredible games, you name it. It just goes to show how powerful and efficient C really is. Okay, so we know how to name things with identifiers, and we know which names to avoid, the keywords. But what are we actually naming? We need places to store our information, our data. And this brings us to our third cornerstone, variables and data types.
Let's go back to our building analogy. You wouldn't try to build a window out of concrete or a support beam out of glass, right? It just wouldn't work. You need the right material for the right job. Well, a program is exactly the same. It needs to know what kind of data it's supposed to be handling.
And these are our main building materials in C. The int data type is for whole numbers, no decimals allowed. If you do need decimals, you use a float. And if you just need to store a single character, like the letter A or an exclamation point, you use a char. The most important takeaway here is that you always have to tell C what kind of material you're planning to store.
So what actually holds these materials? That's where a variable comes in. A variable is just a named container sitting in the computer's memory that's specifically designed to hold one particular data type. And guess what we use to name that container? You got it, one of our identifiers.
And creating one is super straightforward. It's a simple 3-step process. First, you choose your material, your data type, like int. Second, you give that container a label, your identifier, like user_age. And third, you fill the container by giving it a value, like 25. And boom, that's it. You've made a variable.
All right, this is the moment we've been waiting for. We've got our keywords, our identifiers, and our data types. Now we're going to see how they all come together to lay the very first brick in our project. We're going to see how these concepts combine to form our 4th and final cornerstone.
And here it is. Behold, int player score equals 100. It might look like just one short line of code, but this thing is a masterpiece. It's a perfect example of everything we've just talked about working in harmony.
So let's put this line under the microscope. We'll start all the way on the left. What's that first word? Int.
Bam! Right off the bat, we've got two of our cornerstones. Int is one of those 32 special keywords, and its specific job is to tell the program about the data type. It's our way of saying, hey, computer, I'm about to create a container, and it's going to hold a whole number.
Okay, what's next? The name we chose, player_score, what do we call that?
That's right, it's our identifier. It's the unique label we made up for our container. And notice, it follows all the rules, right? It starts with a letter, and it isn't a keyword. It's the perfect name. And here's where it all comes together. The entire statement, from int all the way to that little semicolon at the end, works as a team to create our fourth cornerstone, the variable. We've created a named box in memory called player score, designed it to hold an integer, and we've put the value 100 inside. It's all four concepts in one beautiful, efficient package.
So there you have it, the four cornerstones of C. You've got your keywords, which are the language's built-in commands. You've got your identifiers, which are the names you create. You've got data types, which are the different kinds of information you can work with. And you have variables, the named containers that put it all together. Every single C program is built on this foundation.
When you really stop and think that all those massive, complex programs are built from these same simple, elegant bricks, it makes you wonder, if these are the basic building blocks, the real question is, what kind of masterpiece are you going to build?